In this video, we'll learn about NAT gateways and we will compare and contrast them to NAT instances. So let's start with our diagram here. So here we see again our VPC, just like we've been creating in all of the demos, with a public subnet on the left, a private subnet on the right, and an internet gateway is currently attached to the VPC. And in each of the subnets, we have a virtual router. And again, here's our routing table for our public subnet with a default route towards the internet gateway, giving us internet access from the public subnet. So our public subnet has internet access. However, at the moment, our private subnet does not. So in order to give internet access to our private subnet, we'll create a NAT gateway. And this is going to be very similar to the function of the NAT instance that we saw in a previous lesson. Very, very similar from a functionality perspective. However, the first thing I want to note is this is not an EC2 instance. We're not creating a NAT instance. It's going to serve basically the same purpose as a NAT instance, but it's not running on EC2. It's not an unmanaged service. It's a managed service. It's something that AWS provides for us. And so, much like we saw with a NAT instance, here's a private instance in a private subnet with no route to get out to the internet gateway. So in order to provide this instance access to the internet, we're going to update the route table for the subnet to include a route to a NAT gateway. So now we see the route table for the subnet, a custom route table with a local route and a route to the NAT gateway. So now, as traffic leaves this EC2 instance, it hits its default gateway, which is our router for the subnet. The router analyzes the route table and forwards the traffic to the NAT gateway. And the NAT gateway performs the source NAT translation. It removes that IP address of 10.1.1.23 and it replaces it with an elastic IP. Very similar to what we saw with the NAT instance. Now with the NAT gateway, you can have an elastic IP address get automatically assigned when you create the NAT gateway. It can just take care of it for you automatically, or you can manually go through the process of creating an elastic IP and then attaching it to the NAT gateway. So, after looking at these diagrams and hearing my explanation, you may be thinking, Rick, that sounds exactly the same as a NAT instance. What's the difference? Let's talk about that. Let's talk about some of the advantages of a NAT gateway. Now, number one, it's not based on EC2. There's no EC2 instance required, which means I don't have to patch this thing. I don't have to update it. I don't have to configure scripts for availability. I am not subject to the scaling limitations of an EC2 instance. So there's no EC2 required. This is a fully managed service. When you deploy a NAT gateway, it is automatically deployed in a highly available method within the availability zone. You don't have to script anything. It's deployed across multiple hardware devices within the AZ. And that way, if there's a hardware failure, the NAT gateway will continue to function. You can also create NAT gateways in multiple availability zones. So much like we saw with NAT instances, we may want to create those in multiple AZs. Same thing with NAT gateways. You can deploy NAT gateways in different availability zones. That way, if we have an entire availability zone failure, whatever instances are still up and running in other AZs, they will have a NAT gateway in their own AZ. So you want to bear that in mind. You don't want to centralize your NAT gateway in a single availability zone. If you have instances running in an AZ, you should have a NAT gateway for them in that AZ. NAT gateway automatically scales. You don't have to manually intervene in any way. They will automatically scale up to a maximum of 10 gigabits per second. And if 10 gigabits per second isn't enough, you can create multiple NAT gateways within an availability zone and just split the traffic across them. And again, because it's a managed service, you don't need to patch this. You don't need to perform maintenance. You don't have any operating system access at all, actually. So you don't have to do those things. And it's also going to size itself. It's going to automatically scale depending on the amount of traffic that's going through it. Now, there are some disadvantages to a NAT gateway, but for the most part, these days you should be opting for a NAT gateway whenever possible. There are a few drawbacks. So if these drawbacks are major concerns for you, then maybe a NAT instance still makes sense. But for the most part, you should really be opting for NAT gateways. So the first disadvantage, it can't be used as a bastion host or jump box. So if you have a NAT instance, the NAT instance may exist on your public subnet. That means you can get to that NAT instance from the public internet. You could connect up to it with SSH and use it to jump into other systems that are inside of your VPC. That's a great way to get access to instances inside of your VPC that maybe only have private IP addresses. Well, the NAT instance can reach those instances. So that's what a bastion host is. We use that to access other systems inside of our AWS VPC. You can't do that with a NAT gateway. You don't have access to it. So you can't use it as a bastion host or as a jump box. There's no manual configuration options like port forwarding. So if you have to do more advanced or more customized configurations of NAT, you're not going to be able to do that with a NAT gateway. You cannot associate security groups with a NAT gateway. So with a NAT instance is simply an EC2 instance. I can associate it with whatever security groups I want. I can't do that with a NAT gateway. Now, I can still configure all of my instances behind a NAT gateway with a security group, and I can still configure network access lists on all of my subnets, but I can't explicitly apply a security group to a NAT gateway.